We now talk about uniform random variable. So say x is a uniform random variable. If it has a probability density function, notice I'm talking about probability density function, which can be given as f of t is equal to 1 if t is part of the open interval. So this interval is open in the sense that 0 and 1 are not contained in the interval. So t is element of the interval 0 to 1, where 0 and 1 are not contained in the interval, and it is 0 outside it. So notice that this is a valid density function, because if you integrate it, you get 1. So why do you get 1? So because this integral is same as the integral if you go from 0 to 1 f of t dt. Why is that? Because f of t is 0 everywhere else. So it is 0 everywhere except on this interval. So therefore from minus infinity to 0 f of t would be 0. From 1 to infinity f of t would be 0. So they will not contribute anything to the integral. And this is equal to, since f of t is 1 between 0 and 1, so this will be equal to just 0 to 1 dt, since f of t is 1 in this interval, and you integrate this, you just get 1. A simpler way to see this is to directly see the density function. So notice that before 0 there is nothing. So between 0 and 1, so between 0 and 1, the function is 1. So since this is an open interval, 0 is not contained here, 1 is not contained here. So that's why we have put holes here. And otherwise the function is 0 everywhere. So it is 0 everywhere else. And you can see the area under here is 1. The base is 1. So this base is 1. And the height is also 1. So the area of this rectangle, this is 1. And that is what integration also tells us, that this would be 1. Now in case you take an interval inside 0, 1. So say you take some interval inside 0, 1. So you choose some interval. So now we will take closed interval from a to b. So this is closed interval, which is inside this interval 0, 1. Then probability that x lies between a and b, that is the random variable x, lies in this interval. So this is given as a to b f of t dt. So that is given by this small area. So this area, and this area is integral of a to b f of t dt. But you see f of t is just 1. So this will become equal to integral of a to b dt, and that clearly give us b minus a. So in general we can replace this interval 0 to 1 with some other interval, say alpha to beta, and then say x is uniformly distributed over alpha beta if f of t is given as 1 over beta minus alpha if t is element of alpha to beta and 0 otherwise. So this you can see directly. So again we have to show that this is a valid density function. If you can say minus infinity to infinity f of t dt is 1. But this will hold because we are only worried about interval alpha to beta. This f of t is 0 everywhere else. So we have to just show that this holds. Alpha to beta f of t dt. But f of t is nothing but 1 over beta minus alpha, which is a constant. So you take it out. So you have 1 over beta minus alpha integral alpha to beta dt. So this integral, so let us write this down here. So you have 1 over beta minus alpha, and this integral you compute is also beta minus alpha. So you get 1. So this is satisfied. Now the distribution function of the random variable capital X, which you write here, is given as f of small x. This x comes here, so this is just from the definition. So the distribution function, so we were talking about density function till now. Small f is density function, this is density function. Now we are talking about distribution function. So this will be 0 if x is less than equal to alpha, precisely because we only talk about the open interval from alpha to beta. Here alpha and beta are not in the interval. So between alpha and beta, it will be given as x minus alpha over beta minus alpha. Now this is this simply comes from integrating. So let us integrate it. So we are focused on this part right now. So we are talking about distribution function of this uniformly distributed random variable over alpha beta. So this will be, so we are not worried about minus infinity, we are only worried about starting from alpha. So we are only worried about the interval alpha to beta because f of t is 0 outside this interval. So we are going to rewrite this equation as like this. F of x is integral of alpha to x f of t dt. Now we are talking about this t lies in the interval alpha to beta. So there f of t is 1 over beta minus alpha. So this becomes 1 over beta minus alpha, which will come outside. I'm taking f of t outside, and you have integral from alpha to x dt. So if you integrate this, you get x minus alpha divided by beta minus alpha. And obviously if t is greater or equal to beta, you get 1. So let us do an example. So say x is uniformly distributed over interval 0 to 5, then probability that x is less than 3, so that will be integral from 0 to 3 dt divided by 5. So 5 is the length of the interval. So beta minus alpha, so here alpha is this, beta is this. So beta minus alpha is 5. And in the numerator you can say x minus alpha. So we can use this formula directly. So x minus alpha would be 3 minus 0, which will just give you 3. So you get 3 by 5. X is greater than 4. So x is greater than 4 means that now we are talking about the interval from 4 to 5. So x is greater than 4, and after 5 it is 0. So you have integral going from 4 to 5 dt over 5. So this integral is just 1. X lies between 2 and 4. This is also simple. You take the integral from 2 to 4 dt divided by 5, which is beta minus alpha. You get 2 by 5. Now I want to again give a reinterpretation of this. So probability of x is less than 3. What is this technically? Technically I have to use this formula. So this formula I have to use, that is I have to use minus infinity to 3 f of t dt. But f of t is nothing but 1 over beta minus alpha in the interval from 0 to 5. So we are not worried about 3 to 5 because we are talking about less than 3. And anyway f of t is 0 below this 0. So this is same as integral from 0 to 3 f of t dt. So what is f of t? F of t is 1 over beta minus alpha. So this is what comes down. 1 over beta minus alpha comes down, and we are just left with 0 to 3 dt. That's what comes here. X is greater than 4. So technically this means we are going to find integral from 4 to infinity, that is x is greater than 4. So from 4 all the way from 4 to infinity f of t dt. So again we are only concerned about the interval between 0 and 5. We are starting from 4 and we are only going to remain in this interval 0 to 5, so we end up at 5. So you get 4 to 5, but f of t is nothing but 1 over beta minus alpha. So beta minus alpha is 5 minus 0. This is 5 is beta, alpha is 0. So you get f of t is nothing but 1 by 5. So 1 by 5 comes out, and that's what you get here. X lies between 2 and 4. This you can say this integral from 2 to 4 f of t dt. But again f of t is 1 over beta minus alpha because we are lying in the interval 0 to 5. So again 5 minus 0 gives you 5. So f of t is nothing but 1 over 5, which it has been in this case also. It has been 1 by 5. In this case also it has been 1 by 5. So it comes out, you are left with 2 by 4 dt 5. And that is the example on uniform random variable.